AI found a 9-year-old Linux root bug, RefluXFS explained. Welcome back to Gate and Kernel. Today, we are looking at a Linux kernel vulnerability that had been hiding for nearly 9 years. It is called RefluXFS, and it may allow a normal local user to gain root privileges on affected systems. But what makes this story even more interesting is how the bug was found. Artificial intelligence was used to analyze Linux kernel code and search for a vulnerability similar to dirty cow. And it worked. So in this video, we will quickly explain what RefluXFS is, how the XFS Reflink mechanism works, and why a tiny race condition could break one of Linux's most important security boundaries. What happens if you feed the Linux kernel source code to an AI and give it one simple prompt: find me a vulnerability similar to dirty cow? Could it really uncover a root privilege escalation bug that had been hiding for 9 years? Quali says the answer is yes. Its newly disclosed RefluXFS vulnerability, CVE 2026-64600, proves that the age of AI-assisted Linux kernel bug hunting has arrived. The flaw was found in XFS, a high-performance file system widely used on enterprise Linux servers. At the center of the problem is a feature called Reflink. Imagine copying a 10 GB file. A normal copy creates another 10 GB of data. But Reflink is much faster. The original file and the copy temporarily point to the same physical blocks on the disk. When one file is changed, XFS should create a new private block before writing. This is called copy on write. Normally, that keeps the original file safe. RefluXFS breaks this protection through a race condition. Two threads write to the same Reflink copy at almost the same time. The first thread reads the address of an old physical block. It then briefly releases an inode lock while waiting for a file system transaction. During that tiny window, the second thread completes copy on write and moves the copied file to a new block. The old block now belongs only to the original file. But when the first thread returns, it does not refresh its block mapping. It still holds the old disk address. So the user appears to be writing to a file they own, but the data can flow backward into the original protected file. It is like editing a photocopy, only to discover that the locked original has changed instead. An attacker with a normal local account could potentially overwrite readable files on the same Reflink-enabled XFS volume. That could include the etc password database or an SUID root program, leading to full root access. This is a local vulnerability, not a remote attack. The attacker must already be able to run code on the machine, and the system must use XFS with Reflink enabled. Qualys reports that the change can be written directly to disk, survive a reboot, and leave no obvious kernel log message. One important detail: the AI did not work alone. Qualys researchers narrowed the search area, refined the prompts, reviewed the findings, tested the proof of concept, and coordinated the fix. So this was not an autonomous AI attacking Linux. It was AI-accelerated security research with human oversight. Linux developers have released a fix, and affected distributions are publishing kernel updates. Administrators using XFS should install the latest security updates and reboot into the patched kernel. RefluXFS is more than another Linux bug. It shows that AI is becoming capable of finding complex race conditions hidden inside low-level system code. AI is no longer just helping developers write software. It is starting to uncover bugs that humans left hidden for nearly a decade. RefluXFS is more than just another Linux security bug. It shows how a small synchronization mistake inside a complex file system can remain hidden for years. It also shows how artificial intelligence is beginning to change vulnerability research. AI did not replace human security experts in this case. But it helped them search faster, explore deeper, and find a bug that had been hiding in the Linux kernel for nearly a decade. If you enjoy clear explanations of Linux, computer hardware, processors, and low-level system technology, subscribe to Gate and Kernel. Thanks for watching, and I will see you in the next video.